Assalamualaikum and good day. In previous video, we already looked at a little bit on invariant equilibrium. So in this video, we are going to cover on the example so that we can have better understanding on invariant equilibrium and how we are going to differentiate them between one invariant equilibrium and others. We look at this example. Figure shows an incomplete copper zinc phase diagram. The question is identify X and Y region. X is over here and Y is over here. For X and Y, invariant equilibrium occurs over here. At this point, the three phases coexist. So first we need to determine what are the three phases exist. The first one we have gamma, the second one we have delta phase, the third one we have epsilon phase. So at point X we will only have delta phase only. It is because gamma is already over here and also over here. It means that at X only delta can exist. You need to remember at invariant equilibrium point, the three phases coexist. It means that single phase change into two phases or two phases change into one phase. So at Y, we will have delta plus epsilon phase. The second question, find invariant point. We must remember invariant means we have three phases coexist together. So for this phase diagram, we can see that we have 1 over here, 2 over here, and the third one is over here. At this point over here, we have peritactic invariant equilibrium. For peritactic, we can see gamma plus liquid phase change into another solid phase that we denote as delta. Delta can also change directly into gamma plus liquid. For this point, we have eutectoid invariant equilibrium or eutectoid point, where delta directly change into gamma plus epsilon and gamma plus epsilon can directly change into delta. At this point, once again we find peritactic, where delta in solid phase plus liquid change into epsilon solid phase, and epsilon also can change into delta plus liquid phase. I repeat again, for eutectic, one solid phase transform into two other solid phases upon cooling, or two solid phases change into one solid phase upon heating. For peritactic, one solid and one liquid transform into another solid phase upon cooling, and single solid phase transform into one solid and one liquid phase upon heating. We try another example. Figure shows an incomplete nickel titanium phase diagram. The question is identify A and B region. For region B, we can see the invariant point occurs over here. So at this region we have liquid, this region we have gamma plus liquid, this region we have beta plus gamma. So at region B we will have beta plus liquid. So this point will be eutectic point. Then for region A, we don't have any invariant point connected to it because we have eutectic over here, and then at this point we have peritectic. At region A, we only have single solid phase, which is gamma solid phase, because at the neighbor region we have gamma plus liquid over here, gamma plus liquid, and also beta plus gamma. Every neighboring region have gamma. The second question asks to describe the phase transformation for invariant point. So we can answer that we have two invariant points for this phase diagram. The first one is eutectic. The second one we have peritectic. So for eutectic, single phase region of liquid transform to two phase region of solid. For peritectic, two phase region consists of liquid and solid solution change to single phase region of solid solution. That's all for example on invariant equilibrium. We will meet again in the next video covering on iron-carbon phase diagram, or we also call it as iron-iron carbide phase diagram. Thank you. Have a good day.